welcome to Germany's Path to Renewables 24/7. My name is Jeff Burrell. We're moving past the theory today and looking directly at the proof. Right now, concrete best practice examples are demonstrating that a leading industrialized economy like Germany can successfully run on 100% renewable energy 24 hours a day, 365 days a year. It's happening, and it works. To spotlight these inspiring projects, we've created something truly special for this exhibit. I'm actually right here in the studio where we just wrapped up production on 4 short films designed exclusively for this event. They capture real-world impact across residential areas, industrial production, transportation, and grid security. To kick things off, let's see what is possible in urban areas. 3 out of 4 Germans live in cities, and the number is on the rise. As a result, cities consume the most energy. Renewable energy sources, however, are usually located far from the cities. Energy planners and urban planners of the future face a significant challenge in providing cities with sufficient heat. They'll need to tap into renewable energy sources within cities as well. And they are finding a lot of opportunities. For example, underground, in the sewer system. In Frankfurt, researchers took a close look at the thermal potential of the wastewater treatment plant. Engineers Kun Zhang and Lukas Wilfling are particularly interested in the treated wastewater.
We treat approximately 130 million cubic meters of wastewater each year. The water consistently maintains a stable temperature of between 10 and 23 degrees. All year round. There are fluctuations in the course of a day, but overall, the water keeps a stable temperature.
The engineers are inspecting the treated wastewater. A total of 130 million cubic meters per year flow into the Main River just a few meters away. Ultimately, this provides a heat source that is available 24/7.
We pump the water over our combined heat and power plant. There is a large pump with a thermal capacity of 30 megawatts. The water is then distributed in the city of Frankfurt via our district heating network.
When it comes to new heat pumps, the city of Frankfurt does not, however, want to rely solely on heat derived from wastewater. Frankfurt has numerous data centers that also generate waste heat, and that can be put to excellent use by heat pumps. In addition, the city plans to tap into the geothermal energy available underground by drilling. All of these sources will feed their heat into the city's district heating network, which is set to expand significantly. In addition, the renewable heat generated is also stored in a large water tank. This allows for more flexible operation of the heat pumps. In other words, they run primarily when the sun is shining or the wind is blowing strongly and electricity prices are low.
All of this contributes to decarbonizing Frankfurt's heat supply.
The heating transition is a challenge for every city in Germany. In Berlin, the task is particularly daunting. Nearly 4 million people live here. Well over 100,000 buildings need to be supplied with climate-neutral heat. Like in Frankfurt, Berlin also has a well-developed district heating network. This new office building generates a very large portion of the energy needed for heating and cooling on its own. The key to this is an old railway tunnel located right next to the building.
This is basically a large seasonal heat storage system where we can store heat from the summer for the winter, so we can heat this large office building during the winter.
The former tunnel has been flooded. Now it serves as a year-round storage reservoir. Summer heat from the building is transferred to the 1,500 cubic meter tank via plate heat exchangers. During the winter, 3 large heat pumps can utilize this reservoir. The building maintains a comfortable temperature through so-called radiant ceiling panels in the offices, as well as additional heat exchangers. In the process, the storage tank cools down. In February, the first ice particles form on the panels. And even before the heating season ended, a 1,500 cubic meter block of ice has formed. To be sure there was enough ambient heat available, technicians installed an additional energy source on the roof of the building. In addition to a conventional PV system, the technicians installed a special kind of solar module as well.
Solar energy provides us with radiation that we can use to generate electricity. We can see this in these modules. However, we only capture about 20% of the incoming solar energy. A significant amount of heat is also radiated by the sun. And if we want to harness that, we use collectors like these so-called PVT collectors. PVT meaning photovoltaic and thermal.
PVT modules combine solar cells with thermally open solar collectors. When the sun shines, the cells generate solar power, and at the same time, the entire module heats up. This acts as a heat exchanger on the underside of the solar panels. The thermal energy can then be used to heat the building. And what's more, the heat exchanger also plays an important role in cooling the building. This is important. With 5,000 square meters of glass, the offices would overheat without air conditioning. The ice block's cooling effect can be used into the month of August. Only then will it have completely melted. As the summer comes to a close, the heat pumps take on the job of cooling the building. The heat generated in the process flows into the water reservoir during the day. To prevent the water from heating up too much, it is cooled down again at night using heat pumps. The heat generated in the process flows towards the roof. There, the excess summer heat is released into the night sky via the heat exchangers of the PVT modules.
In contrast to conventional air conditioning, we do not heat the air, so there's no noise due to large fans. Heat is discharged into the sky as radiant heat. This means less noise and less strain on the climate in cities, which would otherwise be heated up by air conditioning systems.
By May 2026, the building had not only experienced its first summer, but also its first winter. 3 large heat pumps, hundreds of PV and PVT modules, various storage systems, and other components had worked together very efficiently. The results were impressive.
The interaction of these components is optimized by AI, so we get a 90% energy self-sufficiency rate even in a big city. In times of geopolitical uncertainty, this is a huge advantage.
The examples from Frankfurt and Berlin show that renewable energy is available on a significant scale, even in urban areas. In the future, both urban planners and energy planners will collaborate with local governments to identify these opportunities when drawing up heating plans. Entirely new business models will be developed, and these models will ultimately promote local growth and prosperity. Within just a few days, by the end of this month, larger cities in Germany are required by law to finalize their municipal heating plans. Smaller cities will have an additional 2 years to complete this. These plans have to outline how the cities intend to meet their energy needs 24/7 using renewable energy sources by 2045. Doing this may feel like a challenge for the municipalities, but it is also an opportunity. If these plans are done properly, they give local governments a chance not only to make their communities climate neutral, but also to trigger resilient and growth-driven processes in the local economy. And that is crucial for local businesses and industry. For a country like Germany, an industrial hub in the center of Europe, affordable energy is crucial, which is why this company generates its own electricity and heat. To do so, it uses, among other things, a large solar power plant with a maximum output of 2.2 megawatts. In addition, an efficient energy management system controls production. For Andreas Müller, the managing director, flexibility is incredibly important at this mid-sized company.
We prioritize flexible operations for both economic and environmental reasons.
You can see this at the production facilities near Memmingen in southwest Germany. One of the machines that consumes huge amounts of energy at this metalworking company is the laser cutter. The ventilation system for the paint booth also requires a lot of energy. Flexible production management makes it possible to prioritize the operation of these systems when sufficient solar power is being generated on site. The production of nitrogen, which is necessary for the manufacturing process, is also adjusted to the energy being created up on the roof. The same applies when they desalinate water and compress air, two elements that are also necessary for manufacturing. Everything is stored in tanks, so the tanks also serve as storage for renewable energy. And depending on demand, this supply is sufficient for several hours or even days. If the solar panels generate more electricity than is needed during operations, the excess energy can be stored in large batteries with a capacity of 1.5 megawatt hours to be used during periods of low sunlight. As a result, 90% of the electrical energy required by the company comes from its very own roof. Now that is efficient. But in this company, they are looking even further into the future.
Essentially, we're building a digital twin to understand the factories and then develop an ideal plant design. The size of the PV systems, the storage units, the thermal storage, PV itself, but also the heat pumps. That's the foundation of the digital twin. We're simulating the future.
To optimize interaction between the individual components, digital twins were created for them. For the laser cutter, the paint booth, the compressed air systems, and all the other components, they each have a so-called digital twin. The parent model contains more than just the statistical data for the components. The model also includes all real-time data regarding their interactions. In this process, all relevant information is in a constant state of juxtaposition, where data is weighed against data to determine the optimal solution. Such a simulation system can immediately incorporate innovations and adjust plant operations as need be.
The digital twin will help us take advantage of flexible electricity prices in the future, and that'll help us work economically and environmentally.
In the future, the company's heating needs will increasingly be met by heat pumps. The goal is to reduce overall energy costs by a large margin despite increased demand for electricity. Thanks to its efficient energy system, the company near Memmingen has a clear roadmap to achieve climate neutrality, and they are not concerned about rising energy prices. The operator of this thermal spa also wants to have that kind of energy independence. In Bad Wörishofen, not too far from the factory in Memmingen, that can be a real challenge though. Because the colder it is outside, the busier it gets inside. Most visitors want to escape into the cozy warmth and usually come in the winter or on days when the weather is bad. As a result, a large portion of the energy is currently still supplied by gas-fired CHP units and gas burners. However, that is set to change. PV modules with a capacity of 1.4 megawatts are already installed on the parking lot canopies. In addition, there is also a solar panel system on the roof of the spa, and a large heat pump is set to take over a significant portion of the heating supply in the near future. And then there are 2 batteries with a capacity of 2.6 megawatt hours. For the facility's technical director, the batteries are a big deal.
The batteries help optimize our own electricity consumption, and of course we can also buy electricity at lower rates during certain times and use it when prices are high.
Electricity for the thermal baths is purchased on an exchange. During the summer, in the middle of the day, the supply of solar power is very high here. In a typical week in June, prices on the exchange would drop at this time. In winter, frequent low-pressure systems bring more wind and, at certain times, also result in lower electricity prices. The utility company that purchases electricity for the thermal baths in Bad Wörishofen buys it when it is particularly cheap. That is, when there's a lot of green electricity available on the grid. So there has to be a demand for electricity. For example, to operate the 14 saunas, or to charge electric cars at the 40 on-site charging stations, or the low-cost electricity is fed into the large batteries. However, the batteries do not have to be fully charged. To reach an optimal economic efficiency, all relevant factors, such as future electricity prices or the output of the company's own PV systems, must be known several days in advance. That is a real challenge. Because weather can change in a matter of seconds, and when that happens, solar panels generate more or less electricity than expected. That in turn affects the battery charge levels. A sudden change in weather will also affect prices on the power exchange. To minimize the risks and strive for optimal operational efficiency, the thermal spa in Bad Wörishofen works with a service provider in Augsburg. The objective of this provider is to evaluate the likelihood of various weather forecasts and, based on this analysis, provide recommendations for operational management.
We developed a mathematical model based on historical data and data on-site, which minimizes risks on-site, weather risks especially, and would optimize the energy flows between the technologies.
The goal is to ensure that nothing at the thermal spa is left to chance. In addition, the capacity of the batteries will be significantly increased in the future to allow for the storage of even more green electricity.
The goal of all of these measures, battery storage, solar power, and so on, is to enable us to purchase eco-friendly green electricity in the most efficient way possible. Our ultimate goal is to use 100% renewable energy.
The examples from Memmingen and Bad Wörishofen demonstrate how intelligent energy management systems can be used to optimize flexibility in both industry and commerce. And that ultimately leads to a reliable and cost-effective energy supply. And if everything goes according to plan here in Bad Wörishofen, then one day you can take a deep dive that is climate neutral as well. Electrification, digitalization, and flexibility are key measures for achieving climate neutral and cost-effective production. This doesn't apply only to industry. even if you just want to reduce the operating costs of your electric car. Making the charging process more flexible is a very sensible approach. In Germany, not only have hundreds of articles and many studies been written about what is known as bidirectional charging, but numerous practical tests have also been conducted. The results are always the same. Yes, it makes economic sense, and yes, it has a positive impact on the grid. A win-win situation if ever there was one. And now, it's actually happening. This isn't just another test run, but is being practiced in real life. Exclusively for you, we met with one of the first German electric car owners who was charging bidirectionally day in, day out. He's not participating in any further studies. For Max Gerstenberger, the time has finally come. He already has an electric car, and now he's getting a new wall box as well.
Hi.
The wall box is mounted on the exterior wall of the house, right next to where the electric car is parked. This particular wall box differs from conventional ones due to its ability to do bidirectional charging. The owner of the electric car can drive a lot of miles for free. There is one prerequisite, though.
It's important to keep your car plugged in as often as possible. So whenever you're at home, just plug it in, set the time you want to leave, the battery level you want to have, and the car will be fully charged.
So this is why I can drive those 16,000 kilometers for free, so to speak.
Exactly.
After signing on, Max Gerstenberger connected his car to his wall box for an average of 10 hours a day and drove about 2,500 kilowatt hours a year. It really paid off for him.
That means I have an extra 800 euros a year.
It doesn't matter when the car is plugged into the wall box at home.
I can use the car exactly the way I want to and still supply battery power to the utility company. When the sun isn't shining and the wind isn't blowing, we can feed the electrical energy from the cars to the grid. And at the same time, when the sun is shining really brightly, just as Lars told me, the electrical energy then flows into the car.
The plan is to get as many electric vehicles as possible to make their battery capacity available to the grid. The batteries draw energy from the grid when there is too much wind and solar power, and feed energy back into the grid when there is too little wind and sun. Studies show that bidirectional charging would help prevent grid bottlenecks significantly. Starting in 2026, several manufacturers are offering electric cars with bidirectional charging in Germany. To offer their customers a bonus, they typically partner with service providers that trade battery capacity on energy exchanges. So to a certain extent, the battery capacity of Max Gerstenberger's car is being marketed here in Munich.
So what happens is, basically, when energy is exceptionally cheap, we buy it and we can store it in the battery, and when energy is more expensive, we can take that energy out of the battery and sell it back to the market.
On energy exchanges in Europe, energy generators and energy traders offer electricity for sale. At any given moment, the amount of electricity on offer must always match the current demand. Otherwise, disruptions occur in the grid. However, it can happen that electricity generators produce more energy or even less energy than they sold on the exchange the previous day for a specific time period. Since the wind is blowing a bit stronger, a wind farm operator, for example, is suddenly producing slightly more energy than predicted. And since the sun is shining a bit less, a solar farm operator is suddenly producing a bit less energy. The wind farm operator is offering a certain amount of electricity, and the solar park operator has a request for a specific amount of electricity. Since electric vehicles can draw electrical energy from the grid very quickly and feed it back just as quickly, the Munich-based energy service provider can accept both offers. Since the surplus energy is generally cheaper than the urgent demand for energy, a trader can earn money based on this difference. What is important to be aware of in this example is that only the difference between the two offers is fed into the electric vehicles. In other words, not the 10 megawatt hours from the wind farm, but only the 2 megawatt hours resulting from the difference.
Sometimes a kilowatt hour in energy is traded not once, twice, it's sometimes 3 or 5 times before it's even stored in the battery or taken out of the battery. So there's no negative impact for the battery. As I said, most of the trading happens sort of on the potential of the battery and doesn't constantly charge and discharge the battery. And even the bit that happens is well within the limit of the battery.
Bidirectional charging doesn't harm the battery. It makes driving an electric car more affordable and advances the energy transition. In the Netherlands, they have been utilizing this technology for several years, like here in Utrecht, for example. Not only cycling is popular, but car sharing is as well. In this system, multiple drivers share a fleet of electric cars. When a trip is over, the car returns to the grid and charges bidirectionally. Matthijs Koch also takes advantage of this service.
Now it's unloading. So you see it turns backwards. So then the unloading starts, and also inside you can see if the green panel goes like this, it's unloading, and if it goes like that, it's loading. Now it gives back electricity to the grid, exactly 11 kilowatts. So it's supporting the neighborhood with its energy.
Okay.
And that's maybe because it's now early evening, so now people start coming home and they have energy demand, and then it can deliver energy back into the grid.
Utrecht is not only home to fleets of electric vehicles with bidirectional charging, it is also one of the most economically successful regions in the Netherlands. Forecasts predict strong population growth in the coming years, up to a 25% increase by 2040. And that can create problems. Rapid growth can lead to the power grid being overloaded. Such bottlenecks are already jeopardizing construction projects, like here in the neighborhood of Meerwede, which was only recently developed. Housing is set to be built here. It is desperately needed. And since parking for 1,000 car-sharing vehicles with bidirectional charging are also being created, more electrical power will be available.
We can enlarge the transport capacity from 5 megawatts to 10 megawatts, which is really helpful to make this new neighborhood, to build this new neighborhood. Otherwise it would have not been possible to build 10,000 houses, but only 5,000 houses.
In this new neighborhood, electric car batteries will be integrated into a smart energy management system. During the day, solar power from neighboring homes can flow into the batteries. And if the local grid is not currently operating at full capacity, cheaper solar or wind power from outside the area can also be fed in. If there is no sun and no wind, no more electricity flows into the batteries. Now some of the stored energy can be fed back into the grid. The neighborhood has more energy available for homes and apartments overall, specifically twice the electrical connection capacity. Twice as many homes and apartments can be built in the Meerwede district compared to what would be possible without bidirectional charging. On the 20th floor of the city administration building, people are thrilled with this new technology. Eva Oosters is a city council member in Utrecht and responsible for sustainable mobility, among other things.
For the economic development, but also for houses, utilities like schools and sports centers, we really need this extra energy or a better level of energy throughout the day. And vehicle-to-grid and bidirectional charging can really help with that. So we are really benefiting from it as a city as well. Yeah.
Utrecht is an example of how bidirectional charging is cost-effective and can even promote economic growth because it benefits the grid. Starting in 2026, this technology is now available to electric vehicle drivers in Germany. And this technology has already started to drive growth here as well. Smart integration of renewable energy creates growth-driven development at every level. it is crucial that a reliable and resilient energy supply is always guaranteed. Supporters of fossil fuels, though, constantly express their doubts that renewable energy can provide enough power 24 hours a day, every day of the year. The truth is, renewables can guarantee reliability and resilience, as the following example from a small town in Western Germany shows. Blackout in Europe. A nightmare scenario. Experts warn that the problems relating to medical care alone would be critical after just one day. In the German state of Rhineland-Palatinate, measures are in place to ensure that power would be restored swiftly after a blackout. Near the town of Fürlen, close to Germany's border with Luxembourg, there is a site that houses 11 battery containers and 7 inverters. Through these inverters, the batteries can draw power from the local grid at any time, as well as feed power back into the grid.
The batteries we have here can store 55 megawatt hours. That is enough to supply the 5,000 nearby households with power for about 12 to 16 hours using only the batteries. We can use this facility to provide a complete backup power supply for the region.
The battery management system ensures that the batteries always maintain a reserve capacity of 11 megawatt hours. In the event of a blackout, the entire plant could be started up independent of an external power supply, even in the event of a cyber attack. Applying a so-called black start, the batteries feed power into the local medium voltage grid. At the same time, this grid is disconnected from the rest of Germany's power grid at a nearby substation. Power from the batteries could then supply the neighboring town of Bekont, an industrial area, the village of Fürlen, and other communities nearby. Having the power supply restored would be important, of course. The local medium voltage grid includes several large solar power systems. These, along with smaller solar power systems on the roofs of neighboring towns, would immediately begin to generate electricity again. And the grid could be stabilized locally via the local substation, which acts as a kind of hub. This would also allow the batteries to be recharged.
At the end of the day, what we have is a complete power supply system running off the battery and solar power generation.
There are approximately 5,000 substations in Germany. These substations convert medium voltage power to high voltage power. Most German wind and solar farms feed their power into the medium voltage grids. Many of these substations could be equipped with batteries capable of black start, just like in Fürlen. Thousands of such small, independent island networks could supply people with electricity in the event of a widespread blackout in Germany.
We would be able to restart the system much faster after a blackout and create a much more resilient grid. We would have 4,000 points that restart on their own and then resynchronize with the 110 kilovolt grid, which are the transmission lines we have here, and then reconnect to the grid. What Spain did in 19 hours last year, we would be able to do in half an hour with equipment like this.
In other words, strengthening resilience through a decentralized supply system. However, to ensure grid reliability, additional technical details must be taken into account. There are still over 200 large conventional power plants in Germany. Generators produce electricity at these plants. And inside the generators, rotors weighing several hundred tons are spinning. And due to inertia, these massive rotors help stabilize the grid. The operators of the battery park in Fuhren also consider it their responsibility to what is known as an instantaneous reserve. To do so, they use additional energy storage devices located inside the battery inverters, so-called capacitors.
We can supply this energy within milliseconds to stabilize the grids. Later, we could then replace 100% of all the rotating masses that are still connected to the grid with synthetic rotating masses. I mean, all those conventional fossil fuel power plants that are still there. Using semiconductor technology, electronics, and the capacitor bank built into the devices, we can fully implement this later.
The battery farm in Rhineland-Palatinate is a wonderful example of how renewable energy sources can ensure the reliability of the power grid 24 hours a day. And in doing so, they also strengthen the resilience of the entire supply of energy. These 4 short films show that it is possible to have a power supply in Germany based on 100% renewable energy that is climate neutral, reliable, cost-effective, resilient, and growth-driven. Stay tuned.